Hello everyone, myself Sindhuja. I'm from ECE and I'm studying in Srinivasa Ramanujan Institute of Technology. And today's my topic is on PN junction diode. I took it from electronic devices and circuits, and the subject code for electronic devices circuits is that 23ECE302, and my roll number is 2340A04A7. PN junction diode. PN junction diode. A PN junction diode is a basic semiconductor device that controls the flow of electric current in a circuit. Characteristics of a PN junction diode. There are few characteristics of PN junction diode like current flow, depletion layer, resistance, current, breakdown voltage. Let us see it by line. Current flow. A PN junction diode allows current to flow easily in one direction but not in other. This is called forward bias and reverse bias respectively. In depletion region, the depletion region layer of a diode is thin during forward bias and thicker during reverse bias. And the third one is that resistance. A diode's resistance increases during reverse bias and decreases during forward bias. Current. A forward bias has a significant forward current while a reverse bias has a marginal forward current. Breakdown voltage. The critical voltage at which a PN junction diode breaks down is called breakdown voltage. And introduction to PN junction diodes. A PN junction diode is a semiconductor device. It made by p-type and n-type materials. It allows current to flow primarily in one direction, functioning as a rectifier. Diodes are widely used in electronic circuits for various applications, including signal processing and power management. Structure of PN junction diode we can observe in the picture. P-type semiconductor on the left side and N-type semiconductor on the right side, and P-type carries the minority charges and N-type carries the majority charges. The PN junction consists of two regions, P-type which has an abundance of holes and N-type which has an abundance of electrons. When these two materials are joined, they form a depletion region where no charge carriers are present. The junction creates an electric field that influences the movement of charge carriers across the junction. Formation of the depletion region. The depletion region is formed when electrons from the N side diffuse into the P side and recombine with holes. This process creates a space devoid of charge carriers, resulting in potential barrier. The width of the depletion region is influenced by the doping levels of p-type and n-type materials, as we observe in the beside picture. And in orange indicates that free electrons, and the white indicates that hole, and middle of that p-type and n-type we can see the formation of depletion region. In forward biasing occurs when the p side is connected to a positive voltage and the n side to the negative voltage. This reduces the width of the depletion region, allowing current to flow through the diode. In this state, the diode conducts electricity and a small voltage drop is observed across it. Between the p-type and n-type, by seeing in the beside picture, we can see that reduced depletion region in forwarding bias. And the flow of electrons is to the right side, and unbiased junction barrier voltage occurs. Forward biased junction barrier voltage we can observe in the beside picture. In reverse biasing occurs when the p side is connected to a negative voltage and n side to a positive voltage. This increases the width of the depletion region, preventing current flow through the diode. In reverse bias, only a small leakage current flows, which is generally negligible. Beside picture, we can observe between the p-type and n-type, depletion region is widened by the reverse bias. Junction barrier voltage is increases by the reverse bias. And the VI characteristics. The current voltage characteristics of a PN junction diode shows distinct behavior in forward and reverse bias. In forward bias, the current increases exponentially with the applied voltage after a certain threshold. In reverse bias, the diode exhibits a small reverse saturation current until breakdown occurs, as we observe in the beside picture. The VI characteristics of PN junction diode is represented in the form of a graph. And the applications of PN junction diodes. PN junction diodes are commonly used as rectifiers in power supply circuits to convert AC to DC. They are also utilized in signal demodulation and detection in communication systems. Additionally, they play a crucial role in voltage regulation and protection circuits. Types of PN junction diodes. There are various types of PN junction diodes, including GNR diodes, Schottky diodes, and light emitting diodes. You can call as LED. Each type has unique characteristics that make it suitable specific applications. For instance, GNR diodes are designed to operate in reverse breakdown for voltage regulation. Types of diodes are junction diode, GNR diode, tunnel diode, Schottky diode, varactor diode, diode, triac, SCR, light emitting diode, that means of LED, photodiode. Advantages and limitations. PN junction diodes are similarly reliable and have low manufacturing cost. However, they also have limitations such as the inability to handle high reverse voltage without breakdown. Understanding these characteristics is essential for selecting the appropriate diode for a given applications. Conclusion. PN junction diodes are fundamental components in modern electronics, enabling various functionalities. Their unique properties allows the effective control of electrical currents in circuits. As technology continues to advance, the applications and innovations surrounding the PN junction diode will expand the further. Thank you.